Hello geometers, it's Miss Backfish here, and I am here to just show you a very straightforward example of using a formula to partition a directed segment into two pieces according to a given ratio. So what I mean is here we're told a ratio. It says find the point P which partitions segment AB in a 2-to-1 ratio. And they're going to give me the coordinates for A and B. And so let me put those on there. For this particular one, A is at 3, 4, so here's A, and B is at 6, 10, so I had a feeling it was up there. Now, a directed line segment implies that we have a starting point and an ending point. They're not equal like just a general line segment. A directed segment means we think of one of these 2 points as the beginning point or the starting point. This problem doesn't tell me which one. If they don't tell you which one, you assume it's the first point mentioned. Okay, so point A would then be my starting point. And the idea is that we are traveling from A to B, and we want to find a point along that path that divides the whole thing into a 2-to-1 ratio. The first number in the ratio would be the starting portion. In other words, the 2 part is on the front end of the segment, and the 1 is in the back. Okay, so there are 2 parts before my point P and 1 part after it. You could think of it like this. Here's point P. 2 parts of the segment are in front of it and only 1 part behind it. Notice that that means we have a total of 3 parts. So it's kind of like we're dividing this into 3 parts. Okay, so the formula. Here's how the formula works. First, I label my 2 points, just like when we do slope or distance formula. One of them is 0.1, one of them is 0.2. Okay, so x sub 1, y sub 1, and x sub 2, y sub 2. And then the formula says you're going to take your starting x and you're going to add to that. We said there's 3 parts, right? 2-to-1 ratio means 2 parts out of 3. I'm going 2/3 of the distance. This can be thought of as if my ratio is A to B, then A over A plus B. In other words, a point that is in a ratio that divides it in a ratio that's 2-to-1 is 2/3 of the way from A to B. Okay, that's what this part is doing. And then this part is the of the way from A to B. It's how far it is from A to B. Well, I'm sorry, from big A to big B here. Getting confused with my little a's and little b's. So this is the formula we use. And we're just going to plug in. Once we label our points, that's all we have to do. We know that the ratio is the A and the B in order, and these are the points. So x sub 1 is 3, plus A is 2 over A plus B is 2 plus 1, and then x sub 2 is 6 minus x sub 1 is 3. 6 minus 3. What I get when I simplify this is going to be my x-coordinate of the point P. Then I'm going to do the same thing for the y values. Y sub 1 plus, it's going to be the same fraction because it comes from the same place. 2/3 of the way along this segment is where I want to go. Then y sub 2 minus y sub 1. So 10 minus 4. So really all we have to do is simplify these and we have our answer. Let's go ahead and do some good order of operations. Subtract this first. That gives me 3 plus 2/3 of 3. 2/3 of 3 is just 2. 3 plus 2 is 5. Here we have 4 plus 2/3 of 10 minus 4 is 6. 2/3 of 6 is 4. 4 plus 4 is 8. So this is my point. This is point P. And if I graph that, let's go ahead and go to 5, 8. We can see that that looks about right. That there are 2 parts ahead of it before at the beginning of the segment. Then we have our point, and then there's 1 part after it. That's the 2-to-1 ratio. 2 parts of the segment are before P, 1 part of the segment is after P. And that is it.